Lesson 2.3, Postulates and Diagrams. The essential question: can you identify postulates using diagrams? What can you interpret from a diagram? We are going to have 7 postulates, and you can see all 7 are here. I know this is overwhelming, so what we're going to do is we're going to go 2 or 1 at a time so we can get in more depth. Now, at the moment, our note should look something like this. You should have the 7 postulates kind of spread out. We have the postulate name, we have the words that go with it, and we have a picture. So let's start with the first 2. Now, it doesn't matter to me the number, the 2.1 and 2.2. What does matter is that you do have the name of the postulate, and in your notes you're going to write the words that go with it, and you are going to write the picture that goes with it. Okay, so let's take a look at these 2 postulates and what they're saying. Now, you can see that the first part of the sentence, the subject of the sentence, is the hypothesis. So if we were to write this in if-then form, we would say if you have 2 points, then there exists 1 line through them. So we're not going to do that. But you have to start off with the 2 points. So we start off with A and B. And the conclusion of the sentence says only 1 line will go through them. Okay, so in other words, this is ridiculous what I'm about to write, but there's no way you can draw another line through those 2 points, because see, that's what would happen, something crooked. So that doesn't make sense. All right, now the second sentence, let's take a look at the second sentence, and notice it starts off with the word line, which is different from what this sentence started off with, 2 points. So you're going to start off with a line. And it says if you have the line, then the conclusion is at least there's 2 points. So you'll be able to find 2 points there. And we can label them whatever letter we want. So the difference between these 2 sentences, one is a conditional and the other one is the converse. So in the picture, for this one, you start off with the 2 points and you get the line through them. And over here, you start off with the line and get the 2 points afterwards. Okay, let's take a look at the next postulate. It says, if 2 lines intersect, then their intersection is exactly 1 point. So anytime you have 2 lines and they come to an intersection, they will only intersect at 1 point. So again, this is ridiculous what I'm about to draw. There's no way we have a line here and a line here. Okay, that doesn't make sense. Now, you have to start off with the 2 lines. That's the hypothesis. And the conclusion is you get a point. Now, back in algebra, you were solving equations. You would graph a linear equation. You would graph another linear equation. And if those 2 did intersect, you learned how to find that intersection point. So what we're doing here in 2.3 is probably very similar to what you did in algebra. Okay, the next 2, this is called the 3-point postulate, and I want you to notice that you're starting off with 3 non-collinear points. So you're going to start off with the points here. You start off with the E, the F, and the D, and you know that there's going to be exactly 1 plane going through them. Now, let me give you an example of this postulate. This is a 3-legged stool. 3-legged stools are one of the most stable stools. They have 3 points, 3 non-collinear points. And when you put them on the ground can act like a plane, and you notice that they're sturdy. You're not going to have a wobbly stool at all. Okay, the next sentence says a plane. Now you start off with a plane, and it says if you see a plane, you know there's going to be at least 3 non-collinear points. So here's a picture of a plane, and you can see that there are 1, 2, 3, at least 3 non-collinear points. Now there really were more points there, but you can find at least 3 non-collinear points. Now if we looked at the upper plane, again you can see, I'll do another color, you can see F, and then you can use D, and you can use B. And you can see that those 3 points are non-collinear. All right, let's take a look at the next 2 postulates. The next postulate says, starts off with if 2 points lie in a plane, so if these 2 points lie in a plane, then the line that's going through them also lies in the plane. So once you plant 2 points, so for example, if there's 2 points in this plane, right here, then we know that whole line that goes through them will also be on the plane. That's what this postulate is saying. The next one is the plane intersection postulate. When two planes intersect, and here's an example of two planes intersecting, then the intersection right here where they meet is going to be a line. And here's kind of a picture of a building where here's one wall and here's another wall, and you can see where the walls meet, those two planes meet, that intersection is going to be a line. Now we learned how to draw that. I hope you remember that. Okay, now let's practice these 7 postulates. It says to state the postulate illustrated by the diagram. Okay, so it looks to me like this means 2 lines intersecting. So if 2 lines intersect, then it looks like the intersection then the intersection is a point. Okay, and so that would be the line intersection postulate. So if you wanted to name it by its title, that would be line intersection postulate. Now, if you can give me the words right here, I will be satisfied. If you can give me the title or the words, it'll be good. Now, look here, it looks like 2 planes. Oops, not spelling right. 2 planes intersecting. If 2 planes intersect, then it looks like the intersection is a line. So if 2 planes intersect, then it is a line. Then the intersection is a line. Now that one is called the plane line postulate. So you start off with some planes, and you know that the intersection is going to be a postulate. So if you memorize the title, or if you give me the words, I'll be okay. Okay, let's take a look at this. It says, use a diagram to write the examples of the plane point postulate. Okay, the way I remember the title is, you're starting off with a plane. So if you have a plane, can you find the points on that plane? So let's talk about this plane right here, plane P. You're starting off with plane P. So the plane point postulate, you have plane P. Then you know you're going to have 3 non-collinear points. So in this case, I can see B, A, and C. So then 3 non-collinear points, B, A, and C. Okay, the next one I want to talk about the plane line postulate. So you're starting off with a plane, and so let's start off with plane P again. And then this postulate says something about that if you have 2 points, then the line containing them will have it. So then for points B and A, there is a line called AB on it. Okay, let's go to the next slide. Okay, use the diagram. Which postulate allows you to say that the intersection of plane P and plane Q is a line? So here are the 2 planes, and here's the line that's going through them. So that one, you can actually write out the words. If 2 planes intersect, then the intersection is a line. Or you can memorize the title, and the title is the plane line postulate. When 2 planes intersect, you get the line. So that's how I remember it. I go, hey, I start off with a plane, I get the idea of a line, and I see these words, and it kind of makes sense to me. Use the diagram to write an example of the postulate. This is the 2-point postulate. So start with 2 points, and so I can say, if you have point A and point B, then there exists one line through And so that's what this 2-point postulate says. Okay, now B says the line point. Okay, so you're starting off with a line. So if you have a line, let's say, if you have line AB, then there exists point A and point B on the line. Okay, line intersection. So this is a line and intersection. So we're going to find two lines. So if line M and line N intersect, and they do in this picture, then they intersect, and it looks like they intersect at point A. So you can see line N and line M, the green line, intersect right here. And so that's what the line intersection postulate states. Okay, so which of the following statements cannot be assumed from the diagram? Okay, we looked at A, B, and F. Are they collinear? A, B, and F. And the answer is yes, because I can see a line through them. Now, points E, B, and D. E, B, and D. I have to say no, because I don't see a line going through them. And you can't assume that that's taking place. Okay, is line AB, that's this line right here, perpendicular to the plane? Now this symbol means perpendicular, means make a right angle. And the answer is yes. How do I know? I see this little right angle symbol here, so I know that's happening. Okay, here is line CD, and they're asking, is this perpendicular to T, so this vertical plane? And the answer is no, because I didn't see any kind of box which indicates that you have perpendicular. The next one says, can you assume that AF, and here's AF right here, I'll put it in green, and oops, green, I got red. AF and BC, can you assume that that intersects at B? And the answer is yes, because we have these two lines. We know two lines intersect at a point, and we can see that it is point B. Okay, and this is our last one. If the given information says that PW and QW are congruent, how can you indicate that? So PW, I'm going to put 2 tick marks to distinguish from the 1 tick mark, and then I'm going to put 2 tick marks so that I know that these go together. So that's how we do it. Name a pair of supplementary angles in the diagram. Remember, supplementary means that the two angles have to add up to 180. And we know that this is, if I use this angle, and I use the angle addition postulate, that those two will add up to 180. So the angles are angle VWQ and the other angle is angle QWT. There is more than one answer, but these are the two that I'm going to put. And this is the end of the screencast.